Hello everyone and welcome back. Today we will be working on an exciting project to create a disk space analyzer using processing. We'll walk through each line of code, breaking it down step by step to understand how it works. By the end, you will have a solid understanding of how to use variables and the arc function to create different segments of a disk space analyzer. So let's get started. Every project in processing starts with setting up the canvas, which is the area where we will draw our shapes and visuals. We use the size function to define the width and the height of our canvas. Here the canvas is 600 pixels tall and 600 pixels wide, creating a square area large enough to display what we want to show. Next, we set up the background color of our canvas using the background function with a deep shade of blue. Next, we will set the stroke weight, and no-fill functions. The stroke function determines the color of the outlines of the shapes we draw. So let's set the stroke color to white, which will make the outlines of our shapes stand out against the blue background. Next is the stroke weight function, which sets the thickness of the outlines. So let's set the stroke weight to 3 pixels. And finally, no-fill function tells processing not to fill the inside of shapes with any color by default. This means that unless we specify, otherwise these shapes will only have outlines. However, we will override this later on to fill specific segments with color representing different disk usage categories. The next step is to define the variables we will use to create our project. As I recall from the previous lesson, variables are like containers that hold values we can use and modify throughout our code. They make our code more flexible and easier to manage. So let's define some key variables for our project. Let's create a variable called ring width and set it to 70. This variable determines the thickness of each ring or section in the disk space analyzer. Imagine it as the width of each segment that represents different categories of disk usage. Next, we define another variable, R2, which is twice the value of ring width. So if ring width is 70, R2 will be 140. This variable helps us easily scale the size of our segments without repeatedly calculating the values. So we can also adjust the thickness of these segments by changing the value of ring width. So no need to recalculate R2 each time. For example, if we change ring width to 50, R2 will automatically update to 100. By using variables like ring width and R2, we can quickly make changes to our code and see these effects without much effort. Next, we need to find the center of our canvas to position our disk space analyzer accurately. We calculate the center by dividing the width and height of our canvas by 2. This gives us the x and y coordinates of the center point, which we store in variables x and y. So if our canvas is 600 by 600 pixels, the horizontal center will be at 300 and the vertical center will also be at 300. Okay, before we can draw anything on our canvas, let's understand this circle's geometry. A circle has 360 degrees in total, which we can represent as 2 pi radians. Now, why radians? Radian is a unit of measurement used in mathematics to describe angles. Processing uses radians to calculate the angles for shapes like arcs and circles. Here is a quick chart to help you understand the conversion between degrees and radians. So let's divide our circle into 14 equal slices to represent different disk usage categories. We'll start from 3 o'clock and move clockwise to create each segment. Now that we have 14 slices, we need to calculate the angle for each slice. And why do we need this? Because if we know the angle for each slice, we can draw the segments accurately around the circle. You will understand this better as we move forward. For now, let's calculate the angles for each slice. There are 14 slices in total, so we divide 2 pi by 14 to get the angle for each slice. After calculating, we find that each slice is approximately 0.4488 radians or 25.7 degrees. This means that each segment will cover an angle of 25.7 degrees around the circle. Now, what is the significance of knowing this angle? Well, it helps us draw each segment accurately and position them correctly around the circle. So let's create a variable called p214 and set it to 2 pi divided by 14. This variable will store the angle for each slice and we will use it to draw the segments in the next steps. Let me break down these values further. Here pi represents half a circle, means 180 degrees. And pi times 2 represents a full circle, means 360 degrees. A full circle is 360 degrees, but we use something called radians to measure angle in processing. So we want to cut the circle into 14 equal slices, so we divide the full circle by 14. With our variables set and angles calculated, it's time to start drawing our segments. We will begin with our first slice labeled as vacation. But before we do that, let me introduce you to the arc function in processing. This function is used to draw arcs, which are segments of a circle. The arc function takes several parameters, including the x and y coordinates of the center of the arc, the width and height of the arc, and the start and stop angles for the arc. The start and stop angles are specified in radians and determines the angle at which the arc begins and ends. You can also specify the mode of the arc, whether it should be open, closed, or pie-shaped. Open arcs have no connecting lines between the start and stop angles. Closed arcs have connecting lines. And pie-shaped arcs are like closed arcs but with an additional line connecting the center of the circle to the arc's endpoint. It is like a slice of pie. So this is the mode we will use to create our disk space analyzer segments. Let's use the arc function to draw the vacation segment. Okay, so we start providing the parameters to the arc function. As the first parameter, we pass the x coordinate of the center of the arc, which is stored in the variable x, which is nothing but the center of our canvas in our case. The second parameter is the y coordinate of the center of the arc, stored in the y variable, which is also the center of our canvas. Next, let's define the width and height of the arc. We'll use r2 times 4 as the width and height, since both the width and height are the same, which equals to 140 times 4 equals 560 pixels. Now we need to specify the start and stop angles for the arc. The start angle would be p214 times 11, and the stop angle would be p214 times 12. So the arc will start at the 11th slice and end at 12th slice of the circle. And finally, we set the mode of the arc to pi. This mode creates a pie-shaped segment with the connecting the ends of the arc to the center of the circle. Now let's use the fill function to color this segment as bright green. So now let's run our code to see how our first segment looks. And there we have it. Let's add more segments to complete our disk space analyzer. Each slice will represent a different category of disk usage, each with its unique color. Next, we will draw the metal segment. So x and y will remain the same as the center of the canvas. The width and height of the arc will be r2 times 3 to create a slightly smaller segment than the previous one. And the start angle will be at pi, meaning 9 o'clock position. And we will end our arc at p214 times 9, which is the 10th slice of the circle. And as before, we will set the mode to pi and fill the segment with a different color. In this case, a bright pink. Now let's run the code to see how the metal segment looks like. Great, the metal segment is now added to our disk space analyzer. Next, we will draw the wrap segment. We will use the arc function again and with the same x and y coordinates. The width and height of the arc will be the same as previous, r2 times 3. The start angle will be at p214 times 9, meaning the 10th slice of the circle, and the stop angle will be at p214 times 11, meaning the 11th slice of the circle. The mode will be the pi and the segment will be filled with the same color as the previous one, a bright pink. Now let's run the code to see how the wrap segment looks like. Okay, great so far. Now let's draw the photos and the work segment using the same arc function. The x and y coordinates will remain the same, as will the height and width of the arc. The start angle for the photo segment will be p214 times 11, meaning the 11th slice of the circle. And the stop angle will be p214 times 13, meaning the 13th slice of the circle. With the mode set to pi, and we will fill the segment with the blue color. For the work segment, everything will remain the same except the start angle, that will be p214 times 13, meaning the 13th slice of the circle, and stop angle will be at pi times 2, meaning the 14th slice of the circle. The mode will still be the pi and we will fill the segment with the same color as the previous one, blue. Now let's run the code to see how these segments look like. And there we have it. Now let's work on video, music, and document segments. For all these segments, we will use the same arc function with the same x and y coordinates, but the width and height of the arc will be r2 times 2 to create smaller segments. And finally, we will draw the document segment with the start angle at p214 times 11, meaning the 11th slice of the circle, and stop angle will be pi times 2, meaning the 14th slice of the circle. Now let's run the code to see what we have so far. And there we go. We have these three segments added to our disk space analyzer. The last thing we need to do is to add a small circle in the center of the disk space analyzer with the same x and y coordinates, but with a diameter of r2. And we will fill the circle with the same color as our background. So let's run the code to see the final disk space analyzer. And there we have it on our canvas. So that is all for today. Do not worry if you didn't get everything in first go. I also struggled when I started creating it, but the first thing I usually do is to draw the visuals on a piece of paper and doing the math on the paper first. Once you have the visuals and math figured out, it's easier to translate everything into the code. So as you practice more and work on similar projects, you will get a better understanding of how to use variables, functions, and geometry to create this dynamic visualization. So yeah, keep learning and take care.